Thank you very much, and thanks a lot for the invitation. I'm really glad to be here. And what I want to present today are the first results of a project that I started approximately 18 months ago, and that is funded by the European Research Council. And just to put it in a nutshell, in this project what I'm trying to look at is the history of genomics across three different organisms: the domestic pig, yeast, and Homo sapiens. And what I'm particularly investigating is the different value that scientists and policy makers attributed to the DNA sequence characteristic of these three organisms as a resource with potential applications for agriculture, for fermentation, or for medicine, and how this changing notion of value shaped the organization of the different initiatives to map and sequence the genome of these three organisms. So today I'm going to present the work on human genomics. There are two postdocs in the project working on pig and yeast as well. And I guess when we talk about human genomics, inevitably this image comes to mind. The image of June 2000, when the first draft of the Human Genome Project was presented, and the then President of the United States, Bill Clinton, pronounced this famous sentence of, "Today we've learned the language in which God created life." And with this, he was meaning the sequence of 3 billion chemical nucleotide units that characterizes the human genetic material. So since then, there's been a bit of a conflation, I think, between the history of human DNA sequencing, the history of human genomics, and the history of the Human Genome Project. And then the Human Genome Project has been associated to an international large-scale initiative. This is a timeline that can be downloaded from the website of the US National Institutes of Health, and they kind of set a start at an end date for the Human Genome Project. A start date in 1990 with the launch by the National Institutes of Health and the US Department of Energy of a program to systematically map and sequence the whole human genome within the next 15 years. And then between 2001 and 2004 with the description of that full human genome sequence in the scientific literature. The first of this paper, that was published in Nature in February 2001, had 256 authors from 48 institutions in 7 different countries. But within these institutions, there were 20 of them that were highlighted in the paper, 20 large-scale sequencing centers that have deployed sort of industrial styles of work that were based in a factory or in an assembly line, and they have contributed most of the sequence. And within these 20 institutions, there were 5 that were later called the genomic G5 that have determined 82% of the human genome sequence. So a bit inevitably, the leaders of these institutions became like the visible face of the Human Genome Project, and they were identified with an international consortium funded by public institutions and also charitable money. For instance, the British Foundation, the British charity Wellcome Trust, and that were committed not only to systematically sequence the full human genome, but also to put the information into the public domain. And in this latter objective, they classed with Craig Venter, the CEO of the company Celera Genomics, who ran a parallel human genome project with the objective of patenting the information. So this is the image of human genomics that we've got if we just focus on the Human Genome Project and on the effort of this G5 international consortium. But my question underlying this project is, what happens if we start the story from the beginning rather than from the end? What happens if rather than retrospectively projecting an image of human genomics that is based on the success story of the Human Genome Project, we see and we look at how DNA was sequenced in the 1980s and 90s, and how different sequencing strategies of human DNA evolved until Bill Clinton's ceremony, the 2001 paper, and the work of the G5. If we do that, the first observation is that, as a historian and sociologist Michael Fortune has already claimed, the human genome did not exist, in the sense that there was never a central structure called the Human Genome Project that funded or coordinated or administered all the effort, from a unitary viewpoint, the efforts of the G5 or the efforts of the signatories of the 2001 paper. What we rather had during the 80s and 90s were different national rather than international human genome projects in Britain, in the US, in France, in Italy, Japan, Canada, Germany, and also a number of regional or international coordinated initiatives such as the Human Genome Organization or the Human Genome Analysis Program of the European Commission. So these national programs started in the mid to late 80s, and at that point, very few of them wanted to sequence the whole human genome. What these programs wanted was to coordinate the activities of already existing laboratories in their countries or in their geographical areas in order to produce a physical map of the human genome. So a set of ordered DNA fragments that encompass either the whole genome or a big part of the human genome, and then these fragments could be sequenced in part or in full. And in fact, the main perspective was to sequence only the fragments in which the laboratories that were being coordinated were interested, normally the fragments connected to different hereditary diseases. So there are historians and sociologists that have studied some of these national initiatives. For example, Paul Rabinow has worked on the French Human Genome Project, Brian Balmer, Peter Glasner, and Harry Rothman in the British Human Genome Project, Robert Cook-Deegan, and more recently Stephen Hill Garner in the US Human Genome Project. But there is not a general study, a bird's-eye perspective of all these different human genome initiatives. So this is what I want to do. And this is not an easy task because it requires incorporating a quantitative side to the traditional historical and sociological studies on genomics. So rather than focusing on a case study on the G5 or on the British or on the French Human Genome Project, we need to tackle all the case studies and look at what institutions were sequencing DNA in the 80s and 90s and how they collaborated between them. So in order to do this, I started myself a collaboration with three other researchers, Jill Viry, Rodri Leng, and Mark Wong. These researchers are experts in bibliometrics and quantitative social network analysis. I am a historian and I was completely ignorant to these techniques before starting this project. And we decided to create two different databases. The first database documented the submissions of human DNA sequences to the European Nucleotide Archive between 1995 and 2005. The European Nucleotide Archive was chronologically the first repository of DNA sequences. It is curated by the European Bioinformatics Institute, that is a satellite of the European Molecular Biology Laboratory. And from the mid-80s onwards, journals, editors made it increasingly compulsory for authors to submit their DNA sequences there before publication. And also, another important thing is that the entries of the European archive are mirrored with other large-scale repositories in the US, GenBank, and in Japan. So the information that is contained here is contained in all the other repositories. So we found around 10 million sequence submissions in the period, so much more than 5 for the G5. Second data set was the first description of these sequence submissions in the scientific literature. We used the database Scopus, and we found 27,000 publications approximately. And with the first data set, we created a number of rankings of the institutions that have submitted the biggest volume of sequence. And with the publication, we created a number of co-authorship networks. So the rankings offer very few surprises, in the sense that 5 out of the 6 institutions that submitted more sequence, more nucleotide units during the whole period, do belong to the G5. And the other one, the University of Washington, was a very important actor in post-genomics. So in the comparison and description of the human DNA sequence once it was released to the public domain in 2001. These institutions start dominating in the ranking around 1996, and in 1996 there was a very important meeting in the Isle of Bermuda, in which the heads of the laboratories of the G5 and the other 20 large-scale sequencing centers decided to coordinate themselves to systematically sequence the whole human genome. So they literally distribute the 46 human chromosomes between them. But what happens with the co-authorship networks? Well, the co-authorship networks offer a much more complex and they offer, we can see above 6,600 institutions that publish DNA sequences, and we can see around a bit below 40,500 ties, 40,500 co-authorship relationships between them. And what I did was to filter this huge network and to only display the connection, the ties, with a value of 4 or more. So only the institutions that have co-authored at least 4 publications between them. An average of 1 publication every 5 years within the 20-year period. And if I do that, so well, basically this was the unfiltered network, and this is the network displaying only the connections between the institutions that have co-authored 4 or more publications. And this is a network with a bit more than 1,000 institutions. And the first thing to notice here is that with the exception of the Baylor College of Medicine, the other institutions of the G5 display a very...
just put the shadow out of the way.
Which is?
The
map, yeah.
There you go.
Yeah. So with the exception of the Baylor College of Medicine, the other institutions of the G5 displayed quite modestly in the network. They are present in the network, but they are neither the institutions that publish the most amount of articles, they are nor the institutions that collaborated or co-authored more with other institutions. And then another striking characteristic is that nationality seems to be a very important factor in the collaboration around human DNA sequencing. We've got Japan here, France here, Germany here, the US in the middle, and this seems to kind of challenge the international nature that we normally attribute to genomic science, and to be consistent with the important role that national sequencing projects had during all the 80s and a big part of the 90s. But even if we focus on the so-called international human genome project, just realize that 4 out of the G5 institutions were based in the same country, in the US. And I think this suggests that when we talk about human genomics as a field characterized by global collaboration, what it is being meant with global is a particular sequencing strategy that originated mainly in the US and to a lesser extent in the UK, but that was not more international than other sequencing strategies that were happening at the same time, as reflected in this complex co-authorship network. So how do we document these alternative sequencing strategies to the G5 and the Human Genome Project? In order to do this, what I have done is applying an algorithm to this network called the Louvain algorithm that enables to isolate clusters of especially strongly connected institutions within the network. And I'm now going to briefly discuss 3 of those clusters. The first one, and I think it was compulsory to talk about it because we are in Canada, is dominated by the University of Toronto. This is the most central institution, the most connected with other sequencers, with other institutions. And the University of Toronto doesn't display very prominently in the accounts of the Human Genome Project. It was not in the 2001 or any of the other papers describing the human genome, but it is recognized for having been the institutions that sequenced the gene of cystic fibrosis. That happened in 1989, and it was a collaboration between the Hong Kong-born geneticist based in Toronto, Lap Chi Sui, and Francis Collins in the University of Michigan. And later on, Collins became the director of the Human Genome Project in the United States. And what it is surprising is that this collaboration, despite being considered very relevant for the history of genomics, especially in Francis Collins's accounts, doesn't display neither in this cluster nor in the whole network. And why? Because the University of Toronto and the University of Michigan only have got 3 co-authorships for the whole period, and this network is filtered and only displays at least 4 co-authorships. What are the main connections of the University of Toronto with the University of Toronto Hospital for Sick Children? They co-author 76 papers, so almost 4 papers per year during the 20-year period. And this is the second strongest connection in the whole co-authorship network. And what is the first strongest connection? Also between a university, the Harvard Medical School, and a teaching hospital, the Massachusetts General Hospital. And what did these institutions publish? They published papers in which they describe the sequence of genes connected to particular hereditary diseases. So very small fragments within the human genome. So it looks like local access to patients and institutional relationships, for example, between a university and a teaching hospital, have been a main factor in the collaboration around human DNA sequencing. Because most of the authors have got double affiliation, and they literally work. From here to here or from here to here. So local, there is a local dimension in the collaborations around human DNA sequencing as much as a national dimension. And in some cases, biotechnology companies, for example here Genentech, they also display as authors in the papers. And I think this suggests that as much as medical value, the sequence also has commercial value, and they could be transformed, for example, in diagnostic instruments to detect the mutations in these hereditary diseases. Later on, another Toronto researcher, Steve Scherer, was involved in the description of the whole sequence of human chromosome 7, the chromosome in which a cystic fibrosis gene is, and he did this in collaboration with Craig Venter, the leader of Celera Genomics and of the private Human Genome Project. And it is interesting that in this publication, we also find the Harvard Medical School and the Massachusetts General Hospital, so the main institutions in the other cluster that have collaborated very intensely between them. So what does this suggest? I think that Venter sequencing effort put together pools, different institutions that have determined partial sequences in the human genome in order to describe bigger sequences within a chromosome and within the whole genome later. And secondly, that this alliance was a confluence of practical interests in the sequence. So the Toronto and Boston people, they had a medical interest in these partial sequences, whereas Venter had an interest in patenting and selling the human sequence information. The second cluster is dominated by what was called the Imperial Cancer Research Fund, now called Cancer Research UK, a British charity that both funds research on cancer and also has got a known network of laboratories to conduct its own research. Since 1979, when human geneticist Walter Bodmer was appointed director of research of this charity, they privilege the genetic approach to cancer. Unlike Boston or Toronto, this charity also published on the description of particular genes connected to disease, in this case BRCA2, connected to breast cancer. But we can see that they tended to recruit bigger lists of authors and institutions in different countries, and in fact the structure of the network suggests that, much more distributed than the other one. And this institution has a complementary expertise at both a technical level. For example, they recruit big sequencing centers to apply advanced genomic technology to particular genes, and also complementary interest in different areas of the human genome. And I think this suggests that, like Celera, the Imperial Cancer Research Fund wanted to sort of create a bottom-up approach to genomics, in which by pooling institutions with interests in different areas of the genome, they would be able to gradually increase their knowledge about the genome. And this publication is a very good example of this, because they use a repetitive sequence that is connected to muscular dystrophy to sort of jump in the genome from one area to another, to another, to another, to another. But this pooling of expertise is, as in Toronto and in Boston, always mediated by a particular medical interest in either one sequence of the human genome or a collection of sequences of the human genome. So the third cluster, and I'm just getting to the end now, is dominated by institutions that either are part of the G5, Baylor College of Medicine, Washington University in St. Louis, or they were big sequence submitters in the European Nucleotide Archive, the University of Washington in Seattle. And I wanted to highlight this publication, because this publication is like a mirror image of the one I showed before, of the Imperial Cancer Research Fund and the repetitive sequences. In this publication, researchers of Washington University, they determined a very long sequence in the human genome of hundreds of thousands of chemical units rather than thousands of chemical units, like in the case of the Imperial Cancer Research Fund. And they use this sequence to find both known and candidate genes. So they are doing exactly the opposite of the Imperial Cancer Research Fund. Rather than building on a known sequence fragment and pooling expertise of other institutions to go beyond that particular sequence fragment, rather than going from the gene to the sequence, they are going from the sequence to the gene. So they are first determining the sequence and then looking for genes in the sequence. One of the authors of this publication was David Schlesinger, who became one of the co-founders of the Genome Sequencing Center of Washington University. And then this Genome Sequencing Center was involved in the description of the whole sequence of chromosome 7. And it is interesting that this was published the same year as the Toronto and Celera and Boston paper, 2003, and in Nature rather than in Science. So exactly like with the description of the whole human genome. But there are differences in the publications. The first one is that this publication is dominated by big sequencing centers, universities, and bioinformatics institutions. So institutions that do not really have a medical interest in the sequence. And I think this suggests that the priority in this publication was determining the sequence rather than applying the sequence to particular medical or commercial uses. So, to conclude, what does this mean? What do these networks say? I think this network suggests that the strategy of systematically sequencing the whole human genome was one among many other different approaches to human genome sequencing in the 1990s. And I think this diversity of ways of sequencing human DNA can connect with John Pixton's idea of working knowledges, particular ways of scientific thinking and doing, that they often coexist in history, like in the 1990s, but then for particular reasons, one of them may dominate over the other. For example, the G5 and sequencing the whole human genome. I think we can start making sense of these ways of sequencing by looking at more local collaborations versus more international collaborations, and collaborations centered in one gene versus collaborations focused on the whole genome. And what is striking here is that the way of sequencing of Washington University and the G5 was by no means the most international one. The Imperial Cancer Research Fund was pulling a wider range of countries and institutions in describing the human genome. And neither the G5 was the only way of sequencing that sought the whole genome. The Imperial Cancer Research Fund was coordinating the institutions to go beyond a particular sequence to wider parts of the genome, and also the more local Toronto and Harvard collaborations, they ended up being redeployed in bigger sequencing publications, like the one chromosome 7 with Celera Genomics. What is characteristic of the G5 is that towards the end, to the 1990s, they kind of prioritize determining the sequence, and they only think about what to do with the sequence, the application, the translation, after the sequence has been concluded. From the sequence to the gene, rather than from the gene to the sequence. And I think this is relevant to current policies wanting to foster innovation in genomics, because one of the main objectives of the NIH and the Wellcome-Trust, the main funders of the Human Genome Project today, is to maximize the health benefits of genetics and genomics. So finding ways to translate, to make medical use of the sequence information that has been piling up in these open access databases. I think the story that I have told you suggests that the answer to this challenge may lay in the past rather than in the present or in the future, because the Imperial Cancer Research Fund or Toronto or Harvard or Boston demonstrate that sequence can be a small scale and can be tailored to the particular necessities of a very local group of people in Boston, in Toronto, in the same city. So, in other words, I think this example suggests that there are other ways of sequencing, there are other genomics that are possible, and we are not predestined to determine one genome after the other and piling up huge amounts of sequence information in the database without having a very clear sense of what to do with it. And this is all. Thank you very much.
Thank you so much. It's a lovely presentation. It's interesting. Lapchi Swedes always say, I gave them the first gene and they've done nothing with it. You know. And then I remember the meeting where they actually presented the full sequence. Both Collins and Venter were in the room. They didn't talk to each other. Yeah. I said to Francis, now that we know the whole sequence, what are we going to do? And he said, you know, questions and comments, please.
I remember when Francis Collins, he was the medical director for the Neurofibromatosis Foundation, when he came up with his great gene story, and it was on the front page of the New York Times. Like, it was such a special moment.
Yeah, no, it was, but it is quite interesting that, for example, well, I've taken advantage of this trip to Montreal, and I've been just in Toronto interviewing a few of the scientists involved in the cystic fibrosis gene, and the account they give of that discovery and the relationship of that discovery with human genomics is very different, for example, from the autobiography of Francis Collins, you know. So they make sense very differently of the events, you know, and I think it has to do with the way they see human genome sequencing, the genome, etc.
Other.
That's a beautiful overview for a lot of reasons. One of them is there is this idea that the genome project was kind of an industrial scale, centralized, organized, and depersonalized, right? It was done by machines, and it all happened. And obviously, you show beautifully how untrue that is. So there is, to me, what you bring into it is the political dimension, or the human, not human genome, the human dimension, in so many wonderful ways. The first is that it was national and therefore political in the sense of, you know, you fly with the birds you know, and the collaborators you already have for other reasons, and you build the genome questions into the genes or the diseases you're already interested in, like cystic fibrosis or BRCA2 or anything like that. It's also, I think, influenced by the fact that Hugo handed out chromosomes to different countries, right? So certain countries got 22 and others got 7. So that was politicized, not in a bad sense, right in the beginning. But what's wonderful is the contrast between your description of what you learned from the Biblometrics versus the heroic story. Because the story is, the G5 are the stories of heroes who became important, or self-important, if you want to be critical, as rhetorical leaders. Lander is a wonderful example. Sulson's another example. The American ones are examples of that. Even Seattle has that behind it, because Lee Hood in Seattle started talking about genome pre-1990 and was a major political force, and a very powerful one, to push forward this idea. And he, in fact, said, let's make it industrial.
Because he was connected with the automatic DNA sequencing.
With applied bio, right? Right.
Exactly right.
So that was this whole notion. It is wonderful how you bring in, whether it's the heroic view of history or the political view, but one thing it isn't is a simply depersonalized industrial view, and I love that comparison. The other one, of course, is the centers like WashU and St. Louis had industrial money, right? I think from Mallinckrodt, so they could set up an institute very early, and may in part explain why they looked for genome and let's worry about the meaning later. Whereas the more health-minded people, I mean, and even Bodmer with his network running ICRF had to be, and was interested in cancer. Lapsi Choi in CF, Francis Collins with that collaboration. That was more the medical. And the backdrop to that I remember was this debate whether we should do it at all. And Richard Lewington said, you're wasting money. So everyone else would then work 20 years to prove him wrong. The counterpoint with Lapsi Choi is amazing because that was published in 89.
Right, exactly.
And I always make the case that has not helped a single patient. It has helped families, that is for genetic counseling, but it has not really helped develop new drugs. And the good old approaches of good standard medical care are still the most important element for CF, is nursing care and respiratory therapy. So that's contrast to me is still amazing, how we say it's going to be precision medicine, we say the genome is the new era, and yet with the concrete examples we have, it's been underwhelming, if you want to kind of take a social critic's view. And in some sense, Lewontin wasn't crazy.
Yeah, no, exactly. And I think because one of the underlying concerns of the project is a concern with translation. So how was the genomic information translated? How they envisage they would apply the information to medicine, and how that shaped the organization of the different projects. And that's why there is also a strand looking at the pig, at the swine genome project, and another at the yeast genome project, because I want to see agricultural translation as well, and translation, for example, in the biotechnology or fermentation industry. And I think this research shows that the human genome, what we understand as the human genome, is only part of what is in the database. So in the database, there are the sequences that the G5 and all the other authors of the human genome paper submitted. But of course, that's not the 10 million records. The 10 million records are other sequences that represent other genomes and that were sequenced for a particular purpose and tailored to the necessities of a particular community. And that's why I think that the sequence that Lapchi determined for cystic fibrosis is different from the sequence that Washington University determined from chromosome 7. And they have different values and they put translation in completely different places. But it is true, the point you have made, that even this small scale and local sequence has not had an easy translation either, has not led to particular milestones, because even though hospitals were very heavily involved in the sequencing, they were research laboratories in hospitals. For example, in the case of Toronto, it was the Research Institute of the Hospital for Sick Children, sick kids, that is, I mean, is closer to the hospital than a big genome center in Washington University, but it's still a bit departed from the day-to-day clinical practice. So maybe the moral story is that there's no translation whatsoever, but that would be very depressing. But I think kind of recovering this small-scale, local, tailored sequencing may be helpful for the purpose of translation.
I think in politics and in science, the history is going to be written by the winners.
Yeah, no, exactly, and that's one of the motivations of the project, to get a from below approach to this. And I think the bibliometrics and the quantitative side is very important, because if not, historians and even anthropologists, we tend to choose case studies. We cannot do everything. I didn't know. I mean, I knew the contribution of Toronto, but thinking about it in the context of large-scale sequencing is not that obvious. You need the data in order to display that.
Other comments or questions? I think we have a Femi by the tail, please.
So, what is your explanation of the dominance now of sequencing, the story of sequencing the whole genome? Why does it dominate our perception of genomics in general? Is it a public relation, of politics, of funding? Do you have a...
Yeah, no, that's a very good question, because basically my project is constructed, so I'm arguing about the heroic dominant account of the G5. But yeah, I sometimes wonder, am I creating a straw man here? Am I exaggerating this heroic point just to make my point? So, what is the dominance? I think there's a dominance of the Human Genome Project and the G5 definitely in the popular literature and in the media, in the journalistic accounts. Everybody knows about the Human Genome Project. If you ask a person in Scotland about who determines cystic fibrosis gene, they wouldn't know. So there is this side. And then in the more academic, historical, and social science literature, I think there's a fragmentation of historians and sociologists that have worked on the Human Genome Project. For example, Stephen Hill Garner is a very good example of that. And there is also another community of historians and social scientists that have worked on medical and human genetics. Susan Lindy, Andy Hogan more recently. There are a few of them. So there's a fragmentation of this literature, and I think this account may bridge this. And why the G5 dominated in the popular literature, I think it's because it represented a very big investment at the point. The NIH made the conscious decision of, instead of distributing their grants among many different institutions, so giving lots of grants with smaller money, to give bigger grants to 5 institutions. I think this didn't imply that they stopped funding the medical geneticists, but they created this scheme. It was a very big investment, and I think that's why it became very popular. And also in the UK, the Wellcome gave an amount of money to the Sanger Institute that was like 20 times more of what the Medical Research Council has given to genomics in the UK. And also the Medical Research Council distributed it among many laboratories, whereas the Wellcome Trust was giving. So it was making these big centers unusual for biomedical research before, factory style, with a lot of money. So that's what made this narrative dominant.
Yeah, thank you very much for your great talk. Absolutely fascinating. I just have a theoretical question, because I was probably I didn't get it, but in your title you have this history from below aspect. I was wondering, so what is the below aspect? So just thinking about a reporter and so on and so forth, you're always having the patient. What is the below, so to say, in your, probably you mentioned that, but and I didn't get it. But
yeah, no, good question. And I should confess that I was using the from below expression in a very lax way. So I mean, probably I wasn't thinking in any particular historian having used it before, and I would need, I mean, if I want to use this in a publication, I would need to theorize that more. Well, but I guess the from below for me, well, means first uncovering all these institutions that contributed to sequencing and have not been acknowledged in the heroic accounts of the G5. One may argue, and I have had discussions within my group with that, but these people weren't doing genomics. They were just, sequencing genes. They didn't want to sequence the human genome. But it is quite striking that many of the publications, even from Toronto, Boston, etc., were in the journal Genomics. So I think this means that what genomics meant in the early 90s and even in the late 80s was not the same as what it means today. You could do genomics by sequencing genes and then pooling those genes and then creating maybe not the genome again, but a genome, that was a collection of fragments. And this approach to sequencing of let's do a small sequences and then pool them in a bigger information representation of the genome, I think is a bottom-up approach to genomics. So it's a genomics from below as well. Let's start with the small and then get bigger. Whereas what the G5 did was exactly the opposite. Let's start with the sequence. I think this publication of the sequence and then looking for known and candidate genes is a very good early example of this. Let's do the sequence and then let's find the genes there. And no worry. Let's not worry about the genes now. Let's worry about the sequence because it's cheaper. Now we have this wonderful apparatus that Leroy Hood has created, first in Pasadena and then in Seattle, and let's use them. So probably that was my meaning from below. And I was very surprised that one of my interviewees in Toronto used the expression bottom up to refer to what they were saying without me saying that. So because that was an analytical category for me, but it has become an actor's category now. I think how intuitively these guys also think about themselves bottom up, below.
Yes.
I have a further comment with regard to the theoretical approach. One of the possible confusion is that from below has been standardized, no? From Roy Porter. And toward the end of your presentation, you indicated that your framework is Pigstone. And Roy Porter and Pickstone had two theoretical approaches with some similarities. However, there were severe differences. And the differences, paradoxically, can be ascribed from the titles, from below rather than bottom up. Pickstone, the syncretism, rather than Porter, that specifically stated, although we could negotiate if he really did it, but he stated what he meant when he said from below.
Yeah.
He also meant from the margins.
Yeah.
But from the margins and from below is a very difficult theoretical approach. And this is probably, if there is on this theoretical, the friction.
Yeah, no. That's a very good observation, and that's why it's great being here, with historians of medicine, because you are much more familiar with that. Yeah, I guess I need to think about the differences of these two approaches, Roy Porter and John Pickstone. But for example, one of the I know John Pickstone much better because, well, he was a great master for me, and I was his postdoc for a few years. And for me, one of the great contributions of Pickstone's ways of knowing and ways of working is that they offer a history of science, technology, and medicine that is different from disciplinary histories. So if you think, for example, about the practice of synthesizing molecules, you can write a history of science in the late 19th and early 20th century that would be different from a standard history of chemistry, as opposed to a history of biology or history of physics. I think for me, thinking about these different ways of sequencing enables me to write a history of genomics that is different from the history of the genomics that the G5 proposed, or also different from the genomics that the Toronto and Boston people, the small sequencers, propose. It's a history that encompasses all the different approaches to sequencing, and then states what genomics was and is and could be, building on these ways of sequencing, rather than picking one notion of genomics and imposing it to my historical account of genomics. So this is what I want to do. From the margins, from the centers, yeah, that's a very problematic concept, but I think my account also qualifies what we mean with global when we think about human genomics as a global endeavor. Because the global, so what they call as the global collaboration between different sequencing institutions that participated in the 2001 paper in which the draft Human Genome Project was described. So 4 out of the 5 institutions of the G5 were from the US. And then this paper in 2001 was written by institutions in 7 different countries. That's not a lot of countries. In my database, there are 100 countries. And the 20 large-scale sequencing centers were in 5 countries. So, is that well? That's international, yes. Is it very international? Is it global? Well, it really depends what you mean with global. Maybe with global, you are trying to impose what is done in very particular places as the way of sequencing, and I'm proposing different ways of sequencing.
Sarah?
Yes, thank you for a lovely presentation. Brings out a lot of interesting new facts, and as such leads me to rethink some of the things I've known about this. So I'm not into genetics, so I am very much limited by the scientific part. But however, from a knowledge perspective, it seems to me that you have touched upon some interesting differences between kind of what people think of their enterprise. Their knowledge is local, it's embedded in the networks they are part of. So the history of previous collaboration is probably important because it predicts maybe future collaborations for most of these players, including, as seen as the links between hospitals and the academic centers in their cities. I'm curious about the role of so the scientific enterprise was going on with a focus on chromosomes and disease-related kind of activities, but then the government and the foundations come in with this big idea, let's do the whole human genome, right? And throw money at it.
Yeah.
And so how does that skew knowledge? Does it bring in new classes of actors? Does it lead to a dismissal of what had been done before as less important? Could you say more about these things?
Yeah.
And
no.
what has it have? What was the outcome, really? And I think Abe mentioned some of that, right?
Yeah.
Yeah, no, exactly. And that's another important thing I found in the networks, because one assumes that after the National Institutes of Health and the Wellcome Trust came with this idea of giving large amounts of funding to less institutions doing big as opposed to small sequencing, that the small sequencing would stop and you would only have the big sequencing. That's not the case at all. You can see, if you trace the chronology of the publications, that these local clusters continue doing small-scale sequencing after 1996, 97. So both things continue running in parallel. And so what the outcome was, so the outcome of the efforts of the big sequencing centers was this whole human genome sequence described in the literature and available in the databases. Whereas the outcome of the smaller sequencing work that was still going on at the same time as the big sequencing work, and still had funding, and most of them from the NIH, so the NIH continued funding those smaller institutions, resulted also in smaller sequences that are also available in the public databases. I think so far, and as you were saying, none of them have made a very big impact in clinical practice. And maybe the bottom line of my story, and building on this last point I did, is that translation needs both. So you need the big sequences, and I wouldn't make the point that we should go back to sequence manually as well, because that would be silly. I mean, we already have the sequence. We cannot delete it from the database. So we still need the big sequences, but maybe we have to complement it with sequencing practices that are, again, small, local, etc. So we need maybe to rescue from history those smaller sequencing centers and smaller sequencing practices from the margins, from below, etc., and put them together with a bigger history of genomics. So a history of genomics that is inclusive also of these small sequencing efforts as much as the big sequencing efforts. And ending with the fragmentation in the literature between a scholarship on the Human Genome Project and a scholarship on medical human genetics. We need to integrate both from a bird's eye perspective. So that would be probably the underlying historiographical point of the talk.
Miguel, thank you so much. Thanks again for a lovely presentation. We're going to have a brief break for coffee. Don't have too much because lunch is coming up in an hour. But do stretch. Thanks.
Okay,
again.
thank you very much.